right, we want to consider the equation y equals x plus 2 divided by the quantity x plus 2. What would that graph look like? Well, you and I know that they're going to cross out, and basically x plus 2 divided by x plus 2 is 1. So the typical graph of y equals 1 is just right across like that. So that's what it would look like, right? Well, yes, but there's a little bit of a problem. What about when x equals 2? When x is 2 and I plug in, not 2, silly me, negative 2 is what I meant to say. When x is negative 2, what happens? Well, when x is negative 2 and you and I plug that in here, we get a 0 in the denominator. We get 0 over 0, and you can't have that. So when x is negative 2, that cannot occur. We can't allow that to occur. But according to this graph that you and I just did, when x is negative 2 right here, it said, hey, it's got a value there at 1. We can't have that. We've got to indicate to people that, hey, when x is negative 2, that can't happen. We can't have any value there. So what we do is we simply come in here right at that little graph, sort of erase where we had that line, and we put a hole to show people that, hey, this line looks just like this, but when it gets to that negative 2 value, there's a hole right there. You can't use that value. And that's what happens. That's how a hole is created on a graph. And we'll see more and more of these as we go on in math. So when parts of an equation cross out, as they did above, we must make sure that we put a hole at the x value where that value can't occur. So let's consider y equals x minus 2 times the difference of 2x and 1 divided by that whole x minus 2 bit. Well, what happens? We look at this and we're like, right away, we're like, hey, that goes away, that goes away. And you're correct. So this is nothing more than the graph y equals 2x minus 1, slope of 2, y-intercept of negative 1. However, remember back a few chapters ago, when we crossed things out, we made sure that we said, hey, you got to know that x in this case can't be a positive 2. So when you and I are graphing this, we want to graph the line y equals 2x minus 1, but we got to make sure when we're at 2, we put a hole. We say, hey, you can't be here. So crosses the y-intercepts negative 1, so we'll put a little dot there. Has a slope of positive 2, so I'm going to go up 2 over 1, up 2 over 1, but remember, it can't be here, so there's going to actually be a hole right there, up 2 over 1. So our line goes like this. That would be the graph of it. There's a hole at x being 2 because we're saying, hey, this is what the graph looks like, but make sure you don't try to plug 2 into the original equation right here because you're going to get an error if you do. So let's consider this. Will there be a hole here? We're like, well, how am I supposed to know? Well, when I look at that top, whenever I see an x squared plus so many x's plus a number, I'm like, hey, does it factor? Well, let's see. Does it factor? Yes, it does. It breaks down to x plus 2 times an x plus 3 because 2 times 3 gives me the 6 and 2x plus 3x gives me the 5x. All over x plus 2. And what do we notice happens? Those cross out. So this equation here is really nothing but y equals x plus 3 with that restriction of what can't x be? We can't let x be a who? Negative 2 in this problem. Boy, I was hitting on the 2's, wasn't I? So let's graph this. It crosses at positive 3, right? And then has a slope of 1, up 1 over 1, up 1 over 1, drop, drop. Now notice at negative 2, we're going to have what? An open little hole there. And then here and here. And so it's going to look, the graph of this would look like that. So the main thing that we really are going to ask is, hey, where's the hole? There's going to be a hole at x being negative 2. And you can just say, I don't care if you really say x can't be negative 2 or just say, hey, there's a hole at x equaling negative 2, which is more of what I would write. Now, let's move on. Let's move to slant asymptotes. These only occur when the degree of the numerator is 1 more than the denominator. Also, it might be the case that there's a hole instead of a slant. So the first thing we sort of do is look for a hole and say, hey, is somebody going to cross out here? That's going to happen when the top will factor and it crosses out with the bottom. Then there's a hole. But sometimes there isn't a hole, and that's going to mean, hey, this might have a slant asymptote. We have our typical horizontal, we have our vertical, and then sometimes there's this slant asymptote, okay, where the line starts coming closer and closer to it at a slant instead of a horizontal or a vertical. And again, that happens when the top is one more than the denominator, the degree. So let's take a look. Which one of these would have a slant asymptote, knowing that none of them have holes? I'm telling you now, none of them factor and are going to cross out. So let's see. This has degree 13.5. Is the top 1 degree higher than the bottom? No. What about the second one? This has degree 2, degree 1. Hey, he is. This will have a slant asymptote. This one, he's 4, he's 5. Is the top 1 degree more than the bottom? No, the bottom is. So, hey, he's not going to have one. Most of the time, you're not going to have a slant. It's only going to happen in a situation like this where the top is 1 degree higher than the bottom. So how do we find the slant? Your favorite thing, we have to do the division. I know you're excited. So let's consider y equals x squared plus 5x plus 2. First of all, I would say, hey, does the top factor, does it cross out? Maybe it's just a hole, but it doesn't. Top doesn't factor. So I'm going to have to go ahead and know, hey, there's a slant here because the bottom is degree 1, the top is degree 2, so the top is 1 degree higher. So how do we do it? This is why I taught you how to do division. So we go ahead and do the division. Okay, fine. X goes in x squared, x times x times x squared, x times the 2, 2x. We must remember that we're coming in here and we're subtracting the whole thing. So x squared minus x squared goes away. 5x minus 2x, that's 3x. We then bring down this guy and then we start the process over. X into 3x, that goes 3 times. 3 times x is 3x. 3 times the 2 is 6. We then subtract the whole thing. Here's the good news. For us, we don't have to worry about the remainder. This right here is all we need. That is where the slant is going to occur. It's going to occur at y equals x plus 3. So if I happen to be graphing this, y equals x plus 3. So there's going to be a slant. Slope of 1 crosses at 3. Up 1 over 1. There's going to be one right in this area. It's going to be a slant. Asymptote is going to be here. That's what's going to happen. Now, please note, I also can see that there's going to be a vertical one at -2. So what's going to happen is you're going to have some line and they're probably going to be coming. Again, I'm just taking a guess here. It's doing something like that and getting closer and closer. Okay, and then you probably got going like that. That's my guess. Okay, so again, slants occur when the top, the numerator, is 1 degree higher than the denominator. If it's not, then hey, there isn't one. And in most cases, there isn't. So we don't have to worry. And again, you don't have to worry about graphing it. All I want you to do is be able to say, hey, there is a slant right here at y equals x plus 3. You have to give the equation. Don't say it happens at x plus 3. It happens at the line y equals x plus 3. There you have it.